Alright, so day 2. We're doing it a little bit earlier this time. Right, let's see what we have. So, Cube Conundrum. You've been launched into the atmosphere from the trebuchet from before. The apex of your trajectory just barely reaches the surface of a large island floating in the sky. You gently land in a fluffy pile of leaves. It's quite cold, but you don't see much snow. An elf runs over to greet you. Alright, you've arrived at Snow Island. There's no snow. We'll be happy to explain the situation. They don't get many visitors. Would you like to play a game? In the meantime, as you walk, the elf shows you a small bag and some cubes, which are either red, green, or blue. Each time you play this game, he will hide a secret number of cubes of each color in a bag, and your goal is to figure out the information. So, okay, you play the game. He hides some number, and your goal is to figure out how many there are. Okay, to get the information. Once a bag has been loaded with cubes, the elf will reach into the bag, grab a handful of random cubes, show them to you, and then put them back in the bag. Okay. You play several games and record the information from each game, your puzzle input. Each game is listed with its ID, like the 11 in game 11, followed by a semicolon separated list of subsets of cubes. Okay. So let's have a look at this input. So we have the game 1. There are 3 blue, 4 red, 1 red, 2 green, 6 blue, 2 green. So are these like the rounds? Like he shows you 3 blues, 4 reds, blah blah. In game 1, 3 sets of cubes are revealed from the bag and then put back again. The first set is 3 blue cubes, and comma. Okay, so this here is one set. This is another, and then this is the last one. The elf would first like to know which games would have been possible if the bag contained only 12 red cubes, 13 green cubes, and 14 blue cubes. Okay, so the games that are possible with this combination. So like you can show all of them. You can start decreasing from 1. Okay. In the example above, game 1, 2, and 5 would have been possible. Oh, right, you get okay. If the bag had been loaded with that configuration, however, game 3 would have been impossible, because at one point the elf showed you 20 red cubes at once. Yes, and there aren't enough. So they're put back. So this is fine. If you add up the IDs of the games that would have been possible, you get 8. Okay, this is fine. So. We have a very specific number of red, number of green, number of blues. So what I'm going to do is you're going to pass these. This is the set of games, blue, red, and you're just going to check, right, is this smaller than or equal? And yeah, you're going to continue that. I don't see any problems here. Okay, let's take this example input for now, and I've organized my code a little bit better since yesterday. Alright, so let's have a day2 input.txt. Here we are. Ooh, that is festive, isn't it? Alright, let's get rid of you and you stay. That's day2.sig. Alright, pub function solve. We're going to take in an input that is an array of strings, right? So the array of const u8 is just an array of char, which is an array of strings, and we're just gonna there we go. We're going to leave it like that, and just same way we started off before. Let's get standard input, standard debug.print. Let's print a slice, which is the inputs. Okay, and let's just go to main. We want to change this to be day2 inputs, and now we don't need this, but we do want day2 and day2 day2.solve. Okay, let's just run. All right, that's all good as we expect. Okay, great. So what we first have to do is pass some stuff. Let's make a struct const RGB, I suppose. Red, green, blue, which is a struct. I can have red, and red can be U size. Let's keep going overkill with the sizes there. Red, green, and blue. Oh, are these no, it wants alright, that looks correct. Okay, that should be good. And I'm just going to declare const part1. Just what do we call this? I'm just gonna say part num of dice. Just dices, dices, whatever. Which is a RGB with red. Oh, actually, is this a syntax? Dot red, yeah. So is it 12 and then green dot green 13 and dot blue 14. Oh, equals, right? Alright. Ah, God, my throat is super itchy today. Right, so there that is. And we're going to have to pass some stuff. So, for input line, we are going to find this here. We're going to split there. Yep. And then we're going to split on these. Yeah, okay. How do I split in Zig? Standard.memory.split. Ah, beautiful. Split. We're going to split U8s. What does it return? Oh, the iterator, right. So online. And I guess we are going to say what we're going to split on, which is this. Let's split iter. Is this a try? No, that's fine. Deprecated. See, use split sequence. Okay. Sequence. Why not? Oh, it's not let's var, of course. And okay, well, this should be good for true times. So game equals split iter dot next dot question mark, because that could be null, and then game input split next. Okay. And now let's standard debug dot print game, and that's still a slice. Game input. We can get rid of that, and let's see what we have. All right, game 1 input, perfect. That's good. That all works, and yeah, that's cool. I'm just thinking that we kind of want to store that that input. Oh no, we don't really need to store it because it's just a sum. So what we're gonna do next, we're gonna say var game num, where we're going to have to just remove 1, 2, 3, 4, 5 characters from this game. Yep. So we're gonna remove 5 characters. Ooh. How do I do that? How do I, you know, the like 5, like if you did this and go? How do I do that? Zig. Remove first x from array. Remove first element from array, return minus. What is this? This is Zig, right? No, this is in no way Zig. zig slice of array. Alright, so we have, okay, we can do that, it seems. What game num, which is, alright, maybe that works. Game num, you run? So we get game num 1, 2, 3, yeah, perfect. And what we want to do next is pass it. Because it's a string, we want to pass it to a number. Zig. Oh no, it's a, oh yeah, because it's going to be if it's 2 characters, then we can no longer use the ASCII table. Okay, string to num, to int. Out of pass string. Yep. Standard dot format. Okay. Try standard dot form dot fmt dot pass int. Fine. Usize. So usize buffer and base. Okay. Usize buffer and base 10. And game num should now just be a regular thing. Alright, so just to test that it is a regular thing, let's times by 2. Perfect. All works. So we have those 3 things. And okay, now we're on to splitting this here. Alright, so what we're gonna do is we're gonna do an iterator, we're gonna check these, and if at any point we reach one that is invalid, we're going to break. Okay. So next, what we want is farm game steps, I guess. It's going to be a game steps. It's going to be a standard.memory dot split sequence. Right, another iterator over the game input. And we are splitting on comma space, and we're going to say we can get rid of these, for game steps up next, we're going to have, oh no, is it while? I think it's while, because it can be eventually null. So game steps, we're going to have step, again, just to test stuff out, print step. Great. 3 blue, 4 red. Wait. Oh, sorry. It's not a comma. It's this. So 3 blue, 4 red. 1 red, 2 green, 6 blue, 2 green. All right. I think that's all working. So we have the step here. Okay, and now we kind of have to go even further, right? Because we have to split each little thing, right? We have to say we have to split 3 blue, and then we have to check the last 4 characters, see if it's blue. We can do index half, I guess. We could be lazy there. Right. Okay. And we're gonna do another one var single dice equals standard.mem.split sequence. Got a lot of splitting. Yeah, I guess that is just big passing. Yeah. Split sequence. You rate on the step, and we want to do comma space. And okay. We're gonna do while single dice dot next dice, and this is gonna say like 2 blue. So if it's just 2 blue, what we need to do is if, and this is similar to last week's, standard.memory dot index of, is this deprecated? No, index of U8 in dice blue. Then we want to split on a space. Oh god, that can't be right? There's so much splitting. Is there a better way to do this? Oh, you know what? I can declare the iterator here. Space split equals standard.mem.split sequence. Well, we'll just roll with it. Dice and on a space. Or we could I guess supposed to be a little bit easier, because at this point we have access to this. We could split on every space, and we know that we can discard the blue. Oh no, that's nice actually. Yeah, we should do that. Can we split sequence? Can it take like can it take like regex like? Learn zig split sequence. I kind of yeah, I wonder if it takes like a regex like type of thing. That would be nice. I don't think this is anything that I want. Split sequence, split token. We can do tokenize. That's it. Yeah, I think we can do this. Tokenize the delimiters. Let's try that. Zig tokenize. Tokenize. Problems with. Okay, let's just see what this guy's doing. Oh god, that's very unformatted code, isn't it? You know what? Let's deprecate. Use tokenized sequence. Okay. U8 step, and we kind of want this, and I'm gonna comment this out for now. Actually, I'm gonna get rid of you for now. So I'm very curious to see what this returns. While single dice dot next. Dice and debug.print. Yep. Dot dice. We have to step there. We're gonna. Right. Let's zoom this out. So. Okay. We print this, and then it prints this. Yeah, you see, it's not actually splitting on both of these. Zig. Oh god, I swear there is a way of doing this. Zig learn. Let's see. Is there anything here? Standard patterns. Tokenize. So there is this. No. God, okay. Tokenized sequence. Okay. You see this here? Will return slices. Return and iterates that iterates over the slices above that are not sequenced in delimiters. Delimiter. See also tokenize any. Tokenize any. Then let's take a look. What do you say? Okay. So we have A, B, C, D, E. So we want to split on. This is interesting. Returns an iterate that iterates over the slice above that are not any of the items in the delimiter. So, okay. Oh, not any of the items. So I guess we could do comma and okay. A comma and space. That might work. Let's get rid of that for now. Okay, there we are. So 3 blue, 4 red. Yeah, that works. So we know we're in the each one is a game step. Let's come that back just so we. Yeah, 3 blue, 4 red. 3 blue, 4 red. Okay, and we know they are put back. I bet part 2 is just not putting them back. Okay. Okay, we are tokenizing. We are seeing. And we are going to do. Each one is a step, right? We are, at this point, we know we are here, so whilst we do this, we can do var dice num, which is try standard.fmt.parseInt. Let's do usize because, yep, let's pass dice 10, var color, color, Queen's English, please. It's going to be single dice.next because we know it comes in a multiples of 2. Single dice.next, dot question mark there. Yep, that's great, that's great, that's great. If color, but yep. If blue, I can't see if it's blue. I have standard.num.equal. All equal. Oh. U8 color blue. And let's just debug print here. So blue and some color. That's none. Else if standard. Let's just yank inside here. Yep. We should go in order. Red, green, let's do that. Red, green, blue. Alright. And we can get rid of you. Expected type U8. Oh, is this what you want? Instead. Expected type const. Oh, wait. No? It's not what you want? What is this? Okay. Expected type U8 and found that. Oh, const U8. What? U8 array? No, what am I doing wrong? Oh, this is probably very silly. Let's check documentation here. All equal. Returns true if all in a slicer equal. Oh no, it's not all equal. It must be equals, right? Oh, yeah, it's not all equal. It's equal. That's it. Great. So, 3 blue, 4 red, 1 red, 2 green, 6 blue. Okay. And whilst we're gonna, yeah, that's great. Okay. We are going, and what we're gonna do is we're going to. Is there any time when you can have like multiple, like you show green, green? I guess not. Okay, so what we're going to do is up here. This is a game step. We're going to do let step dices equals RGB, and I'm just going to copy that from up there. Just replace all of you with 0, and it's not left, it's far. If we come up here, right, we're going to say step dices dot red, Let's do plus or equal just to be safe, I guess. No, let's do equal. Well, yeah, might bring us more troubles than it's worth. Dot green. Dot blue. Okay. We are done with that. And again, step. Well, red, green, blue. And let's see if we've done all of this right. Step dices dots red, step dices dots green, step dices dots blue. And just to make sure. Alright. First step, we have 4 reds, 3 blues. 1 red, 2 green, 6 blues. 1 red, 6 blues. Perfect. It's working like a charm. Now what we need to do is we say, after this step, we say if step dices dot so step dices dot red smaller than or equal to the game, the dices, right? Dot red and step dices dot green smaller than green and step dices dot blue smaller than or equal to dices dot blue. Okay, so this is for every step, right? Every step. If we say that this step is correct, if the step is correct, then we can do a part 1 there, right? We can do part 1 equals 0. And what does it want? It wants the, is it sum, I suppose? 1 plus 2 plus 5 is 8. Okay, part 1, and let's make you a U size. And I'll keep going very overkill on those sizes, but one day, one of the days, it's gonna pay off, I bet. Then we're gonna do part 1 plus or equal to the game num. That's it. Yeah, that's a lot of code. And at the very end of it, we say standard.debug.print part 1. Part 1. Great. Day 3. Oh, right. We don't want to do this each time. Right, we want to make sure each step is correct. Okay. Yeah, we go through. Okay. Yeah, I see. So we want to break out of the loop. Otherwise, only down here do we want to say part 1 is this. We want to inverse this. So let's just say not no demoivre here. So if not, we want to break, but we don't want to break. We don't want to break here. We don't even want to break the step. We want to go all the way up. Outer loop. And break the outer loop. Oh no! Wait, no, sorry. Game loop. It's the game loop there. We don't want to go. We don't want to break like very much all the way. Oh, it's still 15. Why is it 15 now? We do him only after all the steps are completed. Let's see which ones reach this. Reached. I'm probably just getting a little bit confused with these fancy breaks, but it's okay. Game num. 1, 2, 3, 4, 5. Nice. Because if we break, oh, wait, we're breaking the loop. We're breaking the loop, but then we're not yeah, then we're adding anyways. So it's a continue, and then it would have been, yeah, it's continue not break that we want. We want to get rid of this, and we want to continue the outer loop. Then this makes sense. Perfect. So I guess I just explained this logic a little bit. So basically, if we at any point find a step that doesn't meet our criteria, right? So it's not within the bounds of those 13, 14, 15 dice. We just want to say we want to continue, but because we are nested in two loops here, right? We're nested inside this while and also this for, I just want to go straight to the next game, which is the next line. So I want to say, well, I'll just continue with this loop. So in assembly, this will be a jump go-to statement, and eventually, and it will never reach this line of code. So it kind of avoids you having to set a Boolean flag of has reached or something like that. It just jumps straight, and yeah, to be honest, it looks quite nice. Like I think it's pretty obvious what is happening here. All right, part one done. Let's see if we made any mistake, because that's a lot of input. That's that's a whole Christmas tree. Right. 2, 6, 7, 9. All right, very cool. And then part two is going to be when they don't let us add it, right? That bit. The elf says they've stopped producing snow because they aren't getting any water. He isn't sure why the water stopped. However, he can show you how to get to the water source to check it for yourself. It's just up ahead. As you continue your walk, the elf poses a second question. In each game you played, what is the fewest number of dice of each color that could have been in the bag to make the game possible? What is the fewest number of dice of each color that could have been played? That could have been in the bag to make it possible. Oh, okay. So it's not what I thought it was. Okay, game one. So, okay, what's the highest blue value? The highest blue value is 6. What's the highest green value? The highest green value is 2. What's the highest red value? So this is going to be 6 blue, 2 green, 4 red. Yeah. The power of a set of cubes is equal to the number of red, green, and blue codes multiplied together. The power of the minimum set of cubes in game 1 is 48. So 48 times, so that would be 2 times 4, which is 8, times 6 is 48. So then we do that. In the games 2 to 5 would have been 12, 1, 5, 60, 630, 360. Add all of these, and you get the sum. Okay. All right, got it. So I mean, yeah, I guess if we want to do part 1 and part 2 at the same time, we can no longer do that continue, because we must well, keep going. Yeah, so nice logic has to go. Part 1 count equals false. That equals true, and then here we just say part 1 count equals false. Yeah, and we want to say, like, if this wasn't set, if part 1 count and that, and we say if part 1 counts. Yeah, this is what I wanted to. Yeah, okay, well, it's fine. It's nothing special, I guess. We still get 2, 6, 7, 9. Yeah, we still get 2, 6, 7, 9. All right, so that's part 1 logic there. And part 2 logic is a little bit different, because we want to say for each game, we want to say highest number. So far highest dice, which is RGB. Let's copy that again, 13. And oh yeah, it's gonna be 0, 0, 0. Okay, and we're gonna do for each step here. Where are we? Yeah, we're on each step. And that's part one logic, and we're going to say if game highest ice dot green is smaller than step dices dot dot red. Yeah, there is this really slightly annoying thing with Zig. If you start an if statement but don't do the braces, you don't get autocompletes. Yeah. So okay, then we have to say highest dice dot red equals step dices dot red, and I guess we're gonna need this for each one in turn. Red, green. Yep. Red to blue. Yep. Okay. And then, what did it want? Anything specific? Is it just all of them? Yeah, it is all of them. Okay. Part 2, use size is 0. So after this is done, yeah, we want to say part 2 plus or equal to the highest dice dot red times highest dice dot green times highest dice dot blue. Let's just test with the example input for now. 2286. 2286. Wow, first try. Hopefully. Don't speak too soon. 77607. That's right. Cool. That was almost easier than day one. Yeah, very happy we got it. And yeah, actually, you know, the code is, I mean, it's okay. I think there might be better ways to split. I think when I came up with split any on the common space instead of having to do two different like split sequences, that's pretty nice. It's something that I personally would probably have jumped over. So yeah, I'm glad I kind of stopped and said, right, let's just think for a second about this, and it worked. Yeah, very cool. Let's do a quick commit. Oh yeah, I haven't committed day one yet. Okay. Oh, I don't want to input. I don't want to get zig cache or zig out. Oh, let's open Vim within Vim. v.get ignore zig dash cache zig dash out Vim within Vim. All right. We don't want that. We don't want that. We want that. We do want that submodule. Yep. Yep, that's all good. Oh god, we have to commit 2015. Good, go. Now we want to go back. Okay. Day 1 and 2. Smile face. And there we are. Well, thank you so much for watching, if you made it this far. Yeah, I'll see you tomorrow.